Hi, I'm David. Would you please introduce yourself?
Hi, my dad's name is Laughing, and my mom's name is Smiling.
You're kidding.
No, this is my cousin, and I'm joking.
Hello, this video is about the Bechele 2.0 software and its differences to the previous software. If you have not seen the video Animatronic's software before, I recommend to see this first to understand the basic working principle. This is the video I've been talking about. This is the one you should have a look at because it explains the major things about the software. The new version has, of course, some new functions. The new software is much faster than the previous one because the driver for the PWM chip PCA9685 was very slow loading and huge. Also, it was difficult to install from scratch. Since there was no Perl driver available, I wrote one which is now in use. The major difference of the new software is that you may drive a big number of servos with the software. There are of course limits, but these limits are hard to reach. In our example, I configured 64 servos, but you can also drive several hundred servos if your project requires it. As you learned in the animatronics software video, the ConfigL.pm configuration file contains important settings you should consider to adapt in order to start your teaching process using TrackUE.pl. Different from the previous version, the binary files have moved to a new directory, and this is /usr, local, bin, and then Bechele. So this is a subdirectory of the local bin directory. And ConfigL.pm is, as before, in a subdirectory called modules. So what we want to do, let's go to modules. So have a look what's in there, what you can find. As before, you have the configuration file. This is the one in use. And the rest are just template files. So in case you have a different mini computer, you connect your model to. So let's have a look inside. So as before, the globally used constants up here. You have a few things that might be interesting. There's all the description here. Normally you don't need to change that much, except you want to use a gamepad instead of a joystick. For example, if you have a joystick device or if you have a gamepad, then you use here a 1. The serial port is the one that is in use if you use the self-made joystick that we have in use here. And then it's depending on your little computer. In this case, it's a Raspberry Pi 1B. In this case, the device we're talking to is device TTY AMA0. Then, of course, the I2C port is important. Yeah, that's the one where the PCA9685 devices are connected to. So, therefore, of course, you need this device here. But typically, if you, for example, use the one which was from the template, let's say it's a Raspberry, then normally everything is already set correctly. The rest I think is not too interesting. You could theoretically change some frequencies. The next one that is perhaps important is that one. It's a number of servos in use. Currently we use 64, but this is depending on your project. Maybe if you have only 20 servos, then you just type in here 20 instead of 64 or whatever you need. You can have also more servos configured than you really need, because if you don't connect these servos, nothing will happen. So in the end, perhaps it's sometimes a good thing to configure a few servos more, because if you finally find at the end you need some more, then of course you can add some without having the need to make new setting files, for example. This is the refresh rate, can also be changed, but this is 20 Hertz is quick enough. So that means you have every 50 milliseconds you have a change in your movement. Normally this is quick enough for the human eye. You can use a slower one, and then of course you can perhaps use more servos. For example, I think, as I remember, with about 50 milliseconds refresh rate, you can have up to 120 servos, about that, with a I2C bus frequency of 100 kilohertz, which is the standard. So you need a certain speed. well, there's a certain time you have, and if you have a number of servos, each servo needs some time to program or to set on the chip, and if you exceed this number, then and the repeating frequency is too high, then of course you cannot serve all the servos. But you can of course put down the frequency to a lower rate, and then you can have hundreds. So as I remember, as I said, for 20 Hertz, which is normally enough, you can have about 100 servos, 100, 120, something like this. Then the next one, this is also like it was before, this is the joystick setting. The same applies here for the gamepad. Now you don't need to set this anymore, so you have two of these. So if you can swap in between gamepad or joystick. So because the only thing where you really change it is the joystick device you set up here. If you set up this, you can define whether it's using the joystick or it's using the gamepad. So these are some settings where the pin assignments are done. For example, this is for the Raspberry 1B, for example, here. This is for the Orange Pi. As I said, if you use the right template, everything is set already correctly, so you don't need to worry about that. So down here, you see the servo assignments. As I said, we have defined 64 servos for now. So the structure is exactly the same like before. So important is that part here. That's what it tells, what it really does. So it's the servo start, that's the first one. That is really in use during normal movement. And the servo end. This is the real limits for the servos. These are important because you want to have everything assigned to the virtual number inside in between 0 and 4096. All this is explained here in the text, so I don't need to do this in addition. So we have the next one is the invert, that's a 0 or 1. That means here you can define the basic direction of the servo when it moves, because for example, if you move your joystick up and down, and you, for example, want to control, let's say, a mouth up and down or open and close, then of course move down the joystick. I have to move down the lower jaw of your. So that's the reason why you can define one basic setting you can do. And the next one, the 17600 we have in here, is for the SG90 servo, which I use mostly. If you have a different servo, these values might be slightly different. This is just a basic value, so you do not exceed during servo calibration the maximum number of the servo. So this is something you have to set only once, and then you type it in for all servos in use. But this is not too important. These values here are more important because these are the values really when you run the model. So a full joystick movement results in a full movement of your limits of your servo, because you have the range of the servo itself. Of course, you can move. This is normally from 170 to 600, the value. But in the real model, when the mechanics is, for example, limiting the movement of the servo, then it might be less. And that's the reason why here, for example, this is for each individual servo, it's different. And that's a very important thing you have to set up once, because it makes it much easier for you to later teach the movements of the servos, because it helps you finding the right point. So if you go to one limit of your joystick, you're at the mechanical limit of your servo, and opposite, if you go to the other limit, you're on the mechanical limit of the other servo, which makes it much easier to set up everything. And even if you, for example, have a new servo or different type of servo, you want to exchange a servo because one is broken, or you change to a different type, then just setting these values again, you can reuse your old movement files, because we have a virtual movement internally inside the movement files of 0 to 4096, independent of what the servo in reality does. As I said, this makes it much easier to change servos afterwards, or if something breaks, so you don't need to teach everything again. So that helps you a lot. So that's it, configuration file, and that's something you have to change. And as you see from the previous video, animatronic software, there's some slightly different things, some additional things, but only a very few.